Hello and welcome. Have you ever wondered how we can see things that happen incredibly fast? I'm not talking about a speeding bullet, but about chemical reactions that are over in less than a trillionth of a second. Today, we're exploring time-resolved spectroscopy, a powerful technique that essentially lets us film molecules in action. To understand this, let's first quickly recall what standard spectroscopy is. It's like shining a light on a substance and seeing which colors, or wavelengths, get absorbed or emitted. This gives us a unique chemical fingerprint of the material, but it's just a single, static picture, an average over time. It doesn't show us any action. This is where the time-resolved part comes in, turning that single photo into a high-speed movie. To achieve this, scientists most often use a method called the pump probe technique. Imagine it as a perfectly timed photo shoot for molecules. It starts with an intense, ultrashort pulse of light called the pump. This pump pulse acts like a starting gun, hitting the sample and kicking off a process, like starting a chemical reaction. Then, a tiny fraction of a second later, a second, weaker light pulse called the probe arrives. The probe is like the flash on a camera. It takes a spectroscopic snapshot, capturing the molecular fingerprint at that precise moment. The key to this whole process is the ability to precisely control the time delay between the pump and the probe, often down to femtoseconds. A femtosecond is a millionth of a billionth of a second, a timescale so short that light barely travels the width of a human hair. By repeating the experiment many times, each with a slightly longer delay between the pump and probe, we can collect a series of these snapshots. When we arrange these snapshots in chronological order, we create a stop-motion movie, revealing frame by frame how molecules move, how chemical bonds break, and how energy flows. This isn't just a neat trick, it's fundamental to modern science. It allows biologists to watch proteins fold, chemists to observe reactions as they happen, and materials scientists to design better solar cells by tracking how electrons behave after being struck by light. In short, it's our window into the ultrafast dynamics that govern our world. Thank you so much for watching. If you found this explanation helpful and want to learn more about the fascinating tools of science, please consider liking this video and subscribing to the channel. Your support truly helps us create more content just like this.